Welcome to Study Loop.
Okay, so we have this molecule represented by an electrostatic potential map, meaning areas where the partial charges are non-zero are shaded. So you have red in the middle. This means that there's a net plus charge here, and then this blue on the ends means there's a net negative charge. So we would assume that this molecule has some kind of central atom, which we'll call X, and then two regions around it. So it looks like a linear molecule where the outer atom has more electronegativity and is pulling the electrons this way. So then we can check off all that are consistent with that behavior. Okay, so right off the bat, a linear molecule where the outer one pulls electrons more, CO2. Like if we draw the Lewis structure, we know that it's a linear molecule with two double bonds for each oxygen, and oxygen is more electronegative than carbon, so it's going to pull electrons. And so you'll have a net positive charge in the middle, net negative charge on the ends. That's consistent with that. Is there anything else that's linear like that? So SO3 is going to have three regions of electron density, so we can rule that out. That's not applicable. SF2, let's consider that. So sulfur has 6 electrons, and let me erase this. So for SF2, sulfur has 6 electrons. There's 2 fluorines, which each have 7, 14. So this is 20 electrons, and then each one wants 3. Each of the 3 wants 8, so this is 24. So we want 2 bonds. 4 electrons or 2 bonds shared. So it's not going to be linear. Fluorine is way more electronegative than sulfur, though. So it's going to pull electrons, but it's going to look a lot like water, where the dipoles point both in one direction. So the linear geometry is not consistent with this. All right, then we have HCN and HCl. Now, HCl does have a dipole, but it only has 2 atoms, so there's no way that there can be this charge distribution involving 3 different atoms, so we can rule that out. HCN, however, has a central carbon atom, and then it's bonded to nitrogen on one side and hydrogen on the other side. So it does have a linear structure with 3 different atoms. Now, nitrogen pulls electrons away from carbon. However, this carbon and hydrogen situation, carbon is more electronegative than hydrogen, only slightly, but still more electronegative. So pretty much all the charge is still going that way, and you don't have a pretty even distribution of this negative dipole on either end. Meaning CO2 is the only one that is completely consistent with the behavior of the electrostatic potential map.